These are the 3.5 notes. These are the last notes for our pre-calc class. We're going to talk first about what we did earlier this week, which is what is a radian. So it says, what is a radian? And a radian, if you remember, is if you have the circle, and we know what the radius is. The radius is when you have it from the center to the outside. But we're looking for what the radian is. And if you remember, that's when we take the radius and we kind of wrap it around the circle. That would be the radian. So it's a curved version of the radius. How many radians fit around half a circle? It's 1, 2, 3, and then just that little bit more, which is the 0.14. 1, 1, 1, which makes 3.14, which, if you remember, is pi. And then around the whole circle, we would double that, 6.28, which would make 2 pi. For our lesson today, we're going to find the arc length. So you got your definition for a circle of radius r, so radius is r, a central angle of theta. So that right there is a Greek letter called theta, and it just represents an angle. Theta radian subtends an arc whose length is s. And then here's your formula, s equals r theta. So all we're going to have to do is multiply the radius times the angle. Got a little picture here. You would multiply the radius times the angle to get the answer for your arc length. The only thing about this is the angle has to be in radians. So if it's given to us in degrees, we'll just convert it over. Let's try the first problem. Find the arc length when the angle is given in radians. So that means we're not going to have to convert it. We can use pi over 3. So we're going to take our radius, 2, and multiply it by pi over 3, our angle. I'll put that over 1. Multiply across the numerators and across the denominators to get 2 pi over 3. You could label it as feet if you'd like, that feet right there. And that's it. Pretty simple process. And that's going to represent how long this little arc is. Example 2 doesn't give us a picture, but we do the exact same thing. We're going to take the radius and multiply it by the theta, by the angle. And that gets us 38 pi. And if you want to put on the inches, you can. For examples 3 and 4, find the arc length when the angle is given in degrees, round to the nearest tenth. So rounding to the nearest tenth means they're going to want us to put this into a decimal at the end. So we're going to do these slightly differently. We're going to have to take the 150 degrees and convert degrees to radians, which is what we did earlier this week. To do that, we take 150 degrees, multiply it by pi over 180, which gets me 150 pi over 180. And then I just reduce that. When I reduce that, I'll need to type it into my calculator. So just refresh your memory on that. $150 divided by 180. I'm not putting the pi in now because I still want it to be a radian. And then math, enter, enter. So 5 over 6, which I'll write as 5 pi over 6. Once I have that as a radian, I can go ahead and multiply it by my radius. So 10 feet times 5 pi over 6. You could put that over 1 if you'd like. That would give me 50 pi over 6. And now I want to type into calculator. Only at the very end should you type in the pi. So we're going to do 50, 5, 0. And then pi. The pi button is located right here where your caret key, your exponent button is. So we're going to have to hit shift or second, and then this exponent button to access our pi. You could also use 3.14 if you'd like. Just do 50 times 3.14. We'll divide that by 6. And then we'll round to the nearest 10th place. So just one decimal, 26.2 feet. All right, and for the last one, example 4, there's our angle 144. We're going to have to convert that. So 144 times pi over 180 gives you 144 pi over 180, just multiplying across the top and the bottom. And then we reduce this. When we reduce, we don't put the pi in. We're just reducing it and keeping the pi as is. (144) divided by 180. Let's change that over into a fraction. Math. Enter and enter. 4 over 5, which means my radian value would be 4 pi over 5. So that first step is converting it to a radian. And then my second step would be to multiply that by the radius. So the radius times the 4 pi over 5. Go ahead and put that over 1 again. Multiply across the top, multiply across the bottom, and then you type the pi into the calculator. (12 pi), so second or shift, exponent button, pi, divided by 5. Rounded to the nearest 10th place. That would be 7.5, and we're talking about centimeters here, so we'll label that at the end.